I think we were starting understanding of data understanding, right? We started data understanding concept, right? Okay, let's continue our stats class. So our previous session, I was explaining about describing the data. By the time of describing the data, as of now, I explained that measure of centered tendency and some portion from the measure of dispersion also I done it. Okay, let's finish it. Some more concept from the measure of dispersion. After that one, we'll try to be go for visualizing the data. What kind of how we can and what are the type of plots we have it for visualizing the data. Those things we'll discuss about it. Okay? So by the time of measure of dispersion, we understood what exactly the range. Range means the difference between the largest and smallest things, right? And next one is interquartile range. Interquartile range in the sense, so whatever the data we have it, that particular data we can split into, or we can okay, uh, we can converting into five elements that we are calling it's a quartiles: Q0, Q1, Q2, Q3, Q4. So Q0 and Q4, it could be the min and max. Q2, it is your median value. And Q2 and Q1 and Q3 are the quartile 1 and quartile 2. That could be the middle value of the lower half, and middle value of upper half, that we can call it the Q2 and Q1 and Q3. Okay. So let me consider this is your data. This is the data we can able to splitting into five portions. Okay. So this is the median value, and this is the min value. This is max value, right? And so this 74 and 75, it could be the middle values of the lower half. Okay. And this 90 and 92 are the median value of the upper half. Actually, this is the five elements. With if we have these five elements, then we can able to find out the interquartile range. Q1, Q3 minus Q1. Q1, Q3 in the sense 91 minus, and Q1 means 75.5. So the range of interquartile range is 15.5. Okay, this is the way we can find out the interquartile range. And the next one is, so the concept of the measure of dispersion, how the data is distributed with variance, we can know it actually. Variance in the sense, it's a common way to measure that how the data is spread. Okay, how spread out the data values are. Okay, the formula is, it's a sigma square equal to sum of xi minus xi means each and every element. Okay, this is your mean value. Okay, so each and every element we are subtracted with the mean value of that entire data, and we can do the square term so that you will be getting the positive value. Okay, and this is the way, okay, we can able to go for find out the each and every square term and sum of it, and finally we can division with n. Okay, finally we can division with n. So whatever the value we are getting, that we are calling it saying variance. Let me consider that you can easily calculate it with help of Excel also. We have a var function in Excel, so with help of the var function we can do it, or else we can find out the mean value. We can find out the mean value, then we can do the subtraction, then we can do the square term, then we can do the sum, and finally we can apply the division with the sum of values. Okay, so this is the way you can do it. Usually we can work with samples, not on the population. That the situation, this is the formula for the population variance. Okay, but most of the time we are working with the sample data, right? Okay, not on the population data. By the time the formula we can denote it with the s square. Okay, S square in the sense it's a sample variance, and sigma square in the sense it's a population variance. Okay, for the sample variance, so the formula it was little reduced. Here the sample size we can represent it with n. So for example, if we have the 50 samples are there, so we have to division with the 50 minus 1, it's a 49. 49. Okay, the formula is same. It's x bar in the sense it's a sample mean. So your mean mu means it's a population mean. Okay, So sample mean, so each and every element of the sample data which is subtracted with the sample mean, and then we can do the square term, then we can apply the sum, and finally we can division with n minus 1. So this is the way you can able to calculate the single value, that single value representing that how the data is distributed. Okay, but here when you're applying the square term, so you might be getting the, even you have a small variation, even we have a small variation, okay, you will able to get the bigger value. So that's a drawback we are facing in a variance. Clear or not? For example, 4 is your differentiation. Okay, so the difference is 4, but when you do the square term, then we are getting the 16 or not. For example, the difference is 16. When you're doing the square, then you will be getting the some 256 something else, right? So 256 or 226 something, 225 226 something else. 16 to 16, how much? For example, 25 into 25. Okay, if the difference is 25, then you can do the square, then you will be getting the larger values, right? So that is a problem we are facing. Even we have a small variation, even we have a small variation, because of the square term, okay, you are getting the a large value. Okay, that's the reason the concept standard deviation comes to the picture. Okay, it was very simple thing, whatever the formula for the variance, and we are just doing the square root, you're applying just a square root on it. Okay, so standard deviation is a square root of the variance term. It is the most common way to measure that how the data is spread. Okay, the formula is to find the standard deviation. We can go ahead with the sigma, and if it is a sample, then we can go ahead with the s. Okay, so the formula is same or not? Just doing you're just doing the square root. You're just applying the square root of your formula of variance. So this is the way you can easily calculate the standard deviation and variance. For finding the standard deviation variance, we have direct formulas, or else we can go ahead with this particular formulas. With the help of this one, we can build it. Clear? So this is the way you can talk about, measure of, you can go ahead understanding a measure of central tendency, measure of dispersion. When we know that measure of dispersion is central tendency, then only we can easily describe the data. Okay, so here helpful acronym describing the distribution. Okay, when you're talking about the data distributions, okay, in statistics, we are often interested to understand the data set is distributed. Particularly, there are four things to help you how about the distribution. Okay, one is the shape, one is the shape, second one is the outlier, third one is the center value, and the fourth one is the spread value. Okay, this is the four things. These are the four. These are the four things which is deciding, or which is which can help you describe about your data. Okay, for example, if the distribution is symmetrically skewed in one side, then what is mean that? Hmm? For example, if your distribution, when you're plotted the graph, you will get the this kind of curves, right? So this means that data is distributed symmetrically. But sometimes the data, it was not distributed something like this. Maybe maybe it can be distributed something like this. Okay, maybe sometime the data, it can be distributed something like this, right? Okay, so this is the unsymmetric data. This is unsymmetric data. This can be skewed in maybe one side. Okay, when the data is not symmetrically distributed, which means that it's unsymmetric data, it may be skewed in one side or else two side. Okay, maybe second of left side and right side. Some situations, when you're distributed, maybe you might have the uni model, in the sense we have only one mode is there. We have only one mode is there, that we are calling it, say, uni model. For example, when you distributed your plot, or you might have the two modes, two modes. Okay, you have the two modes, so that we are calling it's a bimodal. Okay, so outlier in the sense, let's just imagine yourself, your distributed data here like this, but at some time it was peak something like this. Okay, so here the data is one particular format, but somewhere else it was in some peak value is there. Okay, so this is the thing we are calling its outlier. Okay, or when you distributed, by the time also we can find out the outliers, or we have other different methods to find out the outliers also. Okay, for example, you distributed with frequency table or frequency graph. Okay, so the data it was distributed something like this. You know, somewhere else it was some values are there. Okay, so these two things we can call it outliers. This is the two things we are calling it say outliers. Okay, because of outlier also maybe your model can be affected. So shape is a very important thing, and is there any outliers are there in your distribution, that is also very important thing. And center in the sense we have to find out the middle term that we can do with help of the mean, median and mode concepts. And spread in the sense how the data it was distributed, you already know that with help of the range or interquartile range and standard deviation and variance, with help of this particular concept, with help of these particular concepts we can find out that how the data is distributed. It's combination of this SOCS, that means shape, outlier, center and spread. That acronym is SOCS, is useful acronym that we can use, remember the these four things actually. Okay, it stands for shape, outliers, center and spread things. Okay, let me have some example how we can use it. COCS to describe the distribution. Suppose we have the following data set that shows that hide the sample of 20 plants. Okay, for example, okay, see here's the 20 plants we have it, right? So this 20 plants of data we can try to be figure out the shape. First we want to describe the shape of the distribution. Okay, one helpful way to visualize the shape and just you can easily distribute our thing. For example, histogram. When you plot when you plot this particular values in histogram, if you're getting this a kind of graph, see the data it was symmetric distribution or not. Is the distribution symmetrical or one side? Yes, of course it is symmetrically distributed. Histogram is see the roughly symmetrically. This is the values are not skewed one side or other side. Just only one outlier is there. Okay, we have only one outlier, but when you see this particular graph, it was similar to symmetric distribution or not? Of course. Is the distribution is unimodal or bimodal? So when you see this particular thing, we have only one peak, so that's a unimodal. Outlier in the sense, so when you plot this particular histogram, here some 22 is the one, some it was not in this particular values, it was somewhere else. So this is the value is outlier. Of course, this is the thing we have an outlier. So we can visualize an aspect and distribution and see that the 22 is then a potentially outlier. Okay, and so and center value, right? Center value is we can just go on some of this all things, then we will be getting the mean value. And when you sorted this all the things and find out the middle value. Okay, and mode in the sense most frequently which is the value is what distributed, that value we are calling it some mode. And so you already know that how that spread is doing. Range in the sense max and min, so 18 is the range. And if you want to calculate it the IQR, then we have to be make it the data into the 5 elements. And from that one Q1 and Q3 we have to Q1 and Q3 we can differentiate it. Then you will be getting the interquartile range and standard deviation in the sense before that one we can find the variance, and after that one we can find the standard deviation. And you know how we can calculate it, right? Okay, if you know the formula we can do it, right? So with help of this all values we can describe here. See, using the SOCS as a guide, we are able to describe the distribution of plants heights the following manner. The distribution was unimodal and symmetrical, meaning it only had one peak. It was no skewed one side or other side actually. Okay, the distribution is having outlier which is 25. Maybe you can remove, or we can work on it, or we can handle it. The distribution of the mean is 7.85 and median is 7 and mode is 7. So approximately these three are talking about in the same range, right? Okay, the distribution at the range is 18 and interquartile range is the 3 and standard deviation is this value and the variance is this value. So this is the way you have to be describe your data. If someone is asking that to describe your data in the sense, this is the points we need to talk about it. Okay. Note thus describing which is helpful to use again a good understanding of the shape of the distribution. It has any outlier, where the center is roughly located, and how the data is distributed. Okay, this is a small example, guys, for understanding of this particular distribution data. Okay, any questions?
No, you can keep moving in this way.
Okay, so I hope you understood how the data is distributed and other stuff, right? And if you want to understand the data, this is the things you need to remember it. So visualizing is a important concept actually. So every time for understanding in a numerical term or in a text format, it was very tough to understand. So that visualization, graphical language is a good to understand the data. So there are different kind of visualization concepts are there. So first thing is that let's go for understanding the box plot. I think box plot is not a new thing for you. We already done the file summary data, right? A Q0, Q1, Q2, Q3, Q4, right? Okay, that we are calling it a box plot only. That five elements we can represent in the graph, that we are calling it say box plot. So box plot, sometimes we can call it a box and whisker plot. This is the plot shows that five summary data set. So I already told you, right? So whatever the data set we have it, that data set we have to be represented with the five elements. So one is the min value. So from the data set, whatever the value is the smallest thing, that we are calling it's a minimum, and whatever the element which could be the max, that we are calling it's a maximum. And from that particular distribution or data, we have to find the middle value with help of the median concept. Okay, and when you are calculated the min and median, so the data between min and median, so from that min and median distribution in between the min and median, okay, we might have some kind of data is there, right? So from that particular data we have to calculate the middle value. Okay, from the from this particular lower half we can calculate the middle value, that we are calling it say first quartile. And in between the median and max distribution, you might have the middle value, right, that we are calling it the third quartile. Okay, this is the five plots, sorry, this is the five elements we can visualize this in a data set. Okay, we can visualize this with help of the box plot. Okay, box plot allows to usually easily visualize the distribution of values in a data set using a simple plot, that we are calling it a box plot. Let's see, this is the example, this is the box plot graph. Okay, so this is the min and max, and the box middle value is a median, and this is the q1 and q3. Okay, so if data is distributed symmetrically, the data is distributed symmetrically, okay, then you will be getting the box plot something like this. Okay, so how we can do it in the sense, whatever the data we have it, we can find out the median value and middle values and lower half middle value and upper half middle value. That's enough. With the help of these things we can calculate it. See, for example, we plotted the box plot. Okay, see here the min and max, but middle median value, it was near to q1, not in the not exactly the middle, it was near to the q1. So this means the data is not symmetrically distributed. Even with help of the box plot also, we can find out, or we can say that the data is not symmetrical or symmetrical. Okay, so sometimes the data is distributed in the right side, or for example, how tall is the tallest plant, in the sense, see here, this is the thing also, it was little large, right? Maybe this is the outlier, maybe there might be a chance of getting outliers. Okay, so what percent of the plants are taller than the 19, in the sense the distance, the number of points between the 19 and this 22, that's we're calling it's a percentage of the thing. With help of this one we can calculate the what percent of the data. It means 25 percentage, which means that 70% equal or less than the 19. Okay, so that means less than the 19%, there are 75% of the elements are fall. Okay, so that means this is 0 percentage, q1 means 25 percentage, median is 50 percentage, q3 is 75 percentage, max is, in the sense, it's 100 percentage. So this is the way we can distribute it, or we can plot the graph with help of the box plot. With help of the box plot, we can find out the outliers, and if the data is distributed or not, symmetrically distributed or not, that we can do it actually. Okay, so this kind of box plots we can generate it, or which thing we are using. For example, if you are using the Python programming language too, you can plot it with help of the box plot methods. We can plot that box plot. Okay, and if you're using the Excel, maybe you can plot the Excel also. Okay, and if you're using SPSS also, we can do it. So if you're using our language, we can plot the box plots. The corresponding code, we have only one line of code is there, that we can do it actually. Just we can Google it how we can do the box plot in Python, in the sense you will be getting a small piece of code. With the help of that piece of function, we can plot the box plot actually. Clear? So hopefully you understood how the box plot we can do. And just for understanding, sake of understanding, I can do it in Excel. See, let's have a data something like this. I have a data something like this, right? So you just do what we can do. We just go and select, and this is the comments. This is not box plots, pie charts. This is pie chart. Might have it. Yes, here we have it. Okay. See, this is the graph we are calling it, say, box plot. Okay, so the box plot we can find out charts. Here we have in Excel also we can go ahead and insert, and there are different kind of charts are there. Okay, you can click on any one of the chart and we can do it. For example, I want to get it the distribution, then we just go on to see the distribution. See, this is your distribution. Okay, and so yes, I hope you understood the data in between the 268. It's three elements are there. The data it was in between 68 and 11.6. There is a some 10. I mean in 10. Mhm. See, this is overall distribution. So now Excel also we can find out the box plot, right? Histogram method also we seen it, right? Histogram plot. So this is the way we can do it, and even we have a continuous line is there. Let's see that particular thing as well. Here we have a line plot, right? Here we have a chart line. So even this is also, this is also your data. For example, you can increase the value is 15, 15, 15, 15, 15. So just again we can go ahead with so 15 is having the more some values, right? So 1 2 3 4, there are this many values are there. Okay, 15s, 1 2 3 4 5 6, 6 values are there. And now we can see the box plot how it was looks like. Oh, you might have see previously the box plot is different, now the box plot was changed. Clear? So that's what, if the data is not balanced, then it might be getting this kind of graphs. Okay, so that's for today's session about um, visualization things. Now what we can do till now, whatever I explained, just finish it from the this particular notes. Okay, so we were in the box plot, and tomorrow session we'll talk about stem and leaf plots and the scatter plots and relative frequency functions and density functions as well. Tomorrow we'll finish it this visualization concepts. Even the same things also you might able to get it in Tableau or else Power BI. Okay, okay guys, bye, take care.